Hi, subcourse TR0675, edition 6, maintenance of a diesel electric locomotive and rolling stock. Army Institute of Professional Development, readiness professionalism through growth. Here's a train. However, you stand quiet and in darkness, listen to the distance of the constant locomotive whistle and wonder where the train was going. Momentarily, you have been speculating on why the train was going to some place where the train goes. So there, the where and why and little imagination would go make a grand railroad story, but what would be only a story another railroad is based upon facts, and it's only the story of how trains go and keeps them going that tells the text to tell. At the heart of the story, one word around the railroad revolves around word maintenance. What is maintenance? So when something is broken and repaired or when broken and damaged is repaired, this is maintenance. But there's another more important side to maintenance: is preventive maintenance. This is the inspection, detection, correction of minor defects before they can cause a serious. Your working parts would wear out longer than they should, and you have a major repair maintenance program. If, on the other hand, you check the lube of the oil level in your engine running regularly, checking the adding oil as needed as the engine lasts longer, much longer than that, and is preventive. Why should you know about the railway equipment maintenance? You may be assigned to the Transportation Railway Service, may be responsible for Army railway equipment. If you must know the proper inspection maintenance procedures for you will want to confine for every piece of equipment entrusted to you working as perfectly as ready to do its job. When expected to learn about inspection maintenance railway equipment, three chapters in the text. First, in the chapter 1, giving a general description of three major parts of the train, the rule, regulations governing inspection maintenance Army railway equipment. Then in chapter 2, you are introducing diesel electrical locomotive in terms of major components for the use of the inspection maintenance and the preventive maintenance checks that should be performed before it's operated. Finally, chapter 3 contains a similar discussion on railway rolling stock, discusses preventive maintenance checks for the truck assembly, journal boxes, wheels, safety appliances common to all railway equipment. Chapter 1. To understand how to maintain equipment, you must have a general knowledge of its regulation governing the maintenance. Therefore, the chapter introduces some of the typical railway equipment that Army owns, the regulation that deals with the inspection maintenance, and only the equipment which makes up the three basic parts of the train is covered in this chapter. The locomotive moves on the train of rolling stock and cars containing the things that it moves, and caboose is at the rear of the train. 1, 2. Typically, a U.S. Army railway equipment of vast tonnage of supplies must be moved over the supply military forces theater operation. For the reason the Transportation Railway Services has to do more with the freight train operation passengers. Although the large number of the troops are moved by the railway, and normally that is in the first order of business that does the Transportation Railway Services. However, the operator ambulance for the casualties working trains and to clear the repair of the rail lines, but they are relatively compared to the large number of freight trains that it operates in the theater. The following subparagraphs discuss the three kinds of railway equipment may be found in the Army trains. Let's begin with the front end of the train and work in the rearward. Locomotive. The Army uses two basic diesel electric locomotives, a 0660 120 ton, 1600 horsepower engine, or a 044 60 ton 400 horsepower engine. Those engines may be employed either by the railroad yard. Service may be used singly in multiple units. Note that the term and locomotive engine are used interchangeable in the text, and figure 1 and 2 illustrates both locomotives. Here's a 1660 white classification diesel electric locomotive and a 0440 diesel electric class locomotive. Locomotives are classified under the white classification system according to wheel arrangements. The white system is based on a group of three or more digits. The first digit indicates the number of leading wheels the locomotive may have, a second number the driven of the wheels, and the third number of the trailing wheels. In the absence of the leading or trailing is shown by 0. All wheels of the Army diesel electric are driven by a 0660 or has 6 wheel trucks, each which has the 3 axles with 2 wheel axles, but no leading or trailing wheels. Those are zeros. The 0440 has 4 wheels, and the trucks are 4s. For each of the containing the 2 axles, 2 wheels each, but not leading to the training wheels. The 0 see inserted sketch. Rolling stock. Volume and locomotive in the training of the rolling stock of the railway cars asked to discuss all the same basic design except for the superstructure, which is designed for specific use. Figure 1.3 shows the sum of the more of the common railway cars for use in which each of the design readily apparent. You could haul a car into the boxcar. You probably would not have your hopper or gondola cars. You probably would not if you had a hopper or gondola car. You would want to save the boxcars to haul freight subjects to the pilferages, weather damage, or any other on other hand. You can use boxcars for troop movements if you could not get a passenger car. Here's a boxcar, tanker car, hopper car, high-sided gondola, and a depressed center flat car. Although the cars, when listed in Figure 1 and 5, are 1, 4, and 1, 5, are not presently armed worldwide inventory railway equipment, they are included to show in technical advances in design, construction, commercial railway. As the new equipment is divided into commercial railroads, military transportation players display the responsibility for applying new concepts in design of military railway equipment. The multi-level rack car shown in Figure 1.4 reflects the emphasis of large load capacity. Such equipment is being developed to keep pace with our nation's increase in demand. Of Figure 1.4, the multi-level rack car adequately for efficiently railway transportation moves new automobiles from factories to dealers in rack cars, steadily increasing the number of automobiles carried running to several million annually. Here's a rack car. The piggyback car shown in Part A on Figure 1 is noted the shock absorbing qualities. The providing the mechanism shown in Part of the B in Figure 1.5 inside circled the numbers and are inferred and referred to in the next few sentences. On either side of the sill, A is cushion or rub rail, and B with a pocket, and C every 12 inches. A special tie down D is snapped securely into the place in the pockets. Two chains E are fastened to both tied. Down the device of the equipment being fastened, that the device is locked. When the car is subject to substantial impact, springs and the chains expand as much as 8 inches to absorb possible. Shock to the load of the equipment as the device chains eliminate the usual block required in railway shipping, thereby saving loading and time and cost. Results of test load military vehicles, guided missile systems on rub rail cars reveal the damaging forces ordinarily present in railway shipping are substantially lessened on shock absorbing feature of the cushion rub rails. Caboose. Attached to the rear of the train, a caboose is typically one is shown in Figure 1.6. The train conductor, the rear brakeman riding the caboose. Emergency and safety equipment is stored in it with the engineer fireman on the board. The head brakeman read in the locomotive cab. The train is easily protected at both ends. When an emergency unscheduled stop occurs on the main line, the caboose coupler locates the windows provided by occupants with a unique vantage point from which to view train. Here's Part A, and these are the fastening of the A, B, C, and D, and E. Here's the caboose. 1.3. The publications used in inspection maintaining railway equipment. The publications used in inspection maintenance of the Army Railway Equipment of the Army Regulations 750220001, Technical Bulletin TB 55 2200 2715. 1. Technical Manuals TM 38750 and 55202 and 55203 that specify that the form inspectors are to use when checking equipment that a repairman are to use when working on it. The forms are discussed later in the text. Some railway equipment may be used on a commercial line in this country. To be suitable for the use of the interchangeable, the equipment must meet standards of the Association of American Railroads, Interstate Commerce Commission for the commercial railway equipment. The Army rules regulations mentioned coincided with the ICC, the Interstate Commerce Commission, and the Association of American Railroads. To identify the Army equipment suitable for the interchange, the system used in a USAX and DODX is Figure 1.7 shown. Equipment does marks that USA cannot be operated in the commercial railway lines. It is used in installation located in the training experimental purposes, or may be part of the fleet designed for the use of foreign railroads. Military railway equipment used in interchangeable service under the control of Military Traffic Movement Command, MTCM. This is the railway tanker car. 1.7. The transportation railway services moves more than tons of supplies. Equipment supports military mission theater operations, and therefore most of the trains operates on the freight train. The two basic diesel electric locomotives are the 066 Lewis model and the 120 at 120 tons and 1600 horsepower engine, and the lighter 0440 model at 60 tons and 400 horsepower engine. Locomotives are classified according to their wheel arrangement under the Wyatt classification system. Each kind of Army railway car has basically some design except for the superstructure designed for special purposes. For example, boxcars suitable for the carrying the freight, subject to the pilferage, weather damage, if needed to rise. However, the boxcars can be transported other types of freight or troops. The caboose is at the rear of the train, usually mainly to carry the train conductor and the rear brakeman. Emergency safety equipment are also stored in it where the accident broke down or occurred. The road Army railway equipment is inspected and maintained according to regulations drawn up by the corresponding with the rules in the Interstate Commerce Commission, Association, American Railways, Commercial Equipment. Army publications specify the forms to be used in inspection for the maintenance of the equipment. Now there have been now that you have had a brief description of three basic parts of the train, the locomotive, the railway cars, and the caboose, a short discussion of publications governing the inspection maintenance of the Army railway equipment. In the next chapter, given the details discussion of the diesel-electric locomotive. 1. The diesel-electric locomotive is primarily a power plant mounted on wheels with a control whether the power be used to propel the railway equipment. Electrical equipment is used to transmit power in large internal combustion engines to provide driving wheels. The power plant consists of 1 to 2 multiple cylinder engines which deliver up to 150 to 1600 horsepower more, the top at the speed of 800 to 1700 revolutions per minute. The engine is directly generated. The generator which furnishes the electrical power and traction motor while driving the locomotive through the spur gears on the driving axles. In the lines you have just read in the mentioned number of the major components of diesel electric locomotive subjects in section 1 of this chapter discussed in section 2 are important overall maintenance program for all types of the railway equipment. Preventive maintenance. The sound preventive maintenance program greatly increases the equipment available efficiency. The proper inspection maintenance for the diesel electric locomotive help to keep the rolling stock. However, the requiring complete various forms of the records subject to section 3. Section 1, major components. 2. The modern diesel electric locomotive is assembled for the components. However, this section explains only its major ones at what they are and how they are function. In the paragraphs that follow that discuss the engine itself, the three kinds of generators, the air compressor, the fuel, water tanks, the trucks, and you study whether than figure 2.1 that illustrates the equipment of the diesel electric locomotive is arranged. Also refer to the glossary of Appendix H for the explanation of technical terms that may be unfamiliar to you. Here is a diesel electric locomotive with 1, the horn, 2, the steam engine, steam generator, 3, the traction motor blower, number 2, the hot water heater, 5, the electrical cabinet, 6, the toolbox, 7, the cab heater, engine controls, sandbox fillers, main generator blower, auxiliary generator, main generator and alternator. Engine screwing, air blower, exhaust stack, and the diesel engine governing engine, and the water pump lump, the lube oil engine, cooling water tank, engine temperature switches, lube oil cooler, load regulator, lube oil filter, air compressor, radiator, engine cooling fan, air intake, cooling in fan, shutters. Number 1, classification: light cooling, tractor panel, the hand brake, and the tank, traction motor, battery box, fuel tank, and water tank, and an extra fuel tank. 3, the diesel. The diesel engine is an internal combustion oil burning engine using compression ignition. Such engine gets the powerful burning of the charge of the fuel confined in a space called a cylinder. Ignition occurs where the fuel ignites solely by the heat of the compression caused by the injection of the highly compressed, thereby the heated in the cylinder. Typical diesel engine for the use of diesel electrical locomotives shown in Figure 2.2, which are advantages for the function of the engine. This is from 12 o'clock to 12 o'clock clockwise. East, the exhaust stack, water outlet heater, header, the valve mechanisms, generator, adapter, base cover, engine governor, water pump, lubricating, oil pump, fuel filter, turbocharger. Advantages. The principal economic advantage for the diesel engine over the internal combustion engine is fuel economy. The result for the higher compression ratio, the proportionally higher expansion thermal efficiency of the diesel is constant torque through the speed ranges provided with it pulling over the low speed. It also performs well, reliable in all kinds of weather. In addition, diesel engine is much safer because the fuel is not volatile as gasoline, and 2, exhaust gas are not dangerous as those in automobile engines because they are directly upward dissipated into the atmosphere. Function. The diesel engine changes the heat of the engine, mechanical engineering, turning the generator to produce the electrical engine needed to operate the traction motor, supply motive power. Some of the mechanical engineering is operated by the auxiliary equipment in locomotives or air compressor that supplies the air pressure to the air brake system of the entire train. 2.4, the generators. All diesel electric locomotives has 2 generators, the main and auxiliary one, sometimes a third or a steam generator. The function described in the subparagraph following The main generator shown in the film 1 shown in Figure 2.3 converts all power output in the diesel engine electric power output operating traction motor. Discussed later in the subparagraph, not mainly the generator locomotion of the locomotive, just forward of the engine controls. Figure 2.1 at the part number 12 is the blower at the part of number 10. The main generator is a direct connected with the diesel engine. Turns the armature with the main field. With the generator directly connected with the diesel engine, the armature speed varies. The engine speed is approximately 35 to 1800 RPM. Small engine 300 to 1000 RPM. For a large engine. Even though the speed rotation varies, the main fields are designed to produce up to 1200 volts of direct current for the constant kilowatt output. The armature built and balanced withstand the high-speed rotation, all vibrations incurred in operating with the diesel engine. The traction motors receive electrical engineering for the generator, converting the mechanical engineering at the wheels of the locomotive. The motors are geared to the locomotive axles by driving axles, turning the wheels to supply the locomotive traction effort. The motors are mounted on the axles and the trucks for the locomotive. This is a traction generator, an exciter, and auxiliary generator with armature. The auxiliary generator produces 10 kilowatts of electricity for the power needed to operate the equipment. It also charges the store battery, supplies the current for the low voltage circuit required for the lighting of the locomotive, operating the fuel pump of the motor, exciting the main field. Once the battery is supplied with the power to start the diesel engine, auxiliary generator begins to operate either by the belt driven from the staff of the diesel engine, but the main generator, usually mounted on the ladder's frame, is shown in Figure 2.3. The auxiliator shown in 2.1 part number 11 and Figure 2.3 are given gear driven from the main generator shaft. A steam generator is also installed. Locomotives used in the passenger ambulance trains to produce steam heat for the cars in cold weather. It is an independent oil-fired heating oil unit operating automatically once it has been started. Figure 2.1, the steam generator is parted. Number 2. 2.5, the air compressor. And the compressor which is shown in Figure 2.4 compresses the air used to operate much of the equipment on the diesel electric locomotive. Such equipment includes air brakes, reverb, electro-pneumatic contactors, sanders, window wipers. Compressors may be engine-driven, either given directly belts maintain generator shaft through the flexible coupling air compressor into compression cycle 2. This is an air compressor from the top of the 12 o'clock. Air intake filters, oil loader, safety valve, lube, oil filler cap, crankshaft, crankcase, oil drain plug, oil level gauge, intercooling. Low pressure compresses air which passes through the cooling system of the high pressure cylinder, compresses it, and still further before feeding the air to the main reserve. Reserves are kept at the pressure of 125 to 140 pounds. 2.6. The tanks. Both fuel and water tanks are carried on the diesel electric locomotive. The fuel usually suspends beneath the underframe between the trucks. Contains fuel oil from operating the diesel engine, and notes the parts numbered in 35, 36 Figure 2.4, and water expansion. The tank containing the water for the cooling engine is located at the highest point of the engine cooling water system. Part number 19 Figure the 2.1 system is designed to carry out the dispersing excess heat of the generated in the engine. 2.7. The trucks. The main function of the trucks is to provide connection between the axle wheels, the locomotive itself. The trucks must carry the weight of the locomotive superstructure distributed through the wheels and to the rails. There also may be lateral thrusts ride over the uneven rails without excessive tilting and swaying of the locomotive. The trucks also provide mounting for the brake rigging and traction motors. Army Diesel Electric has either 6-wheel swivel 3-motor trucks, 2-wheel swivel 2 trucks. Figures 2.5 shows a 4-wheel swivel 2-motor truck used in 0440 diesel electric locomotive. Main difference between a 4-wheel and a 6-wheel truck is that the wheel locomotive is distributed over the wider surface by a 6-wheel one than the greater working surface on the rails, giving locomotive traction, effort, pulling power. 2.8 Summary. A diesel electric locomotive is made on the complex parts: internal combustion diesel engine burning diesel fuel oil ignited between the heating compressor within the cylinder process known as compression ignition. A main generator is connected to the engine. Mechanically engineering output generated to produce the electric current needed for the power or the traction motors to turn the locomotive wheels. This is a truck. The brake cylinder from the 12 o'clock. Brake cylinder, baluster, center plate, brake cylinder, truck wheel, traction motor, power cable, brake hanger, brake shoe, truck axle, frame, end of the box, journal box, brake lever, and journal box. The auxiliary generator provides the power for the needed operator that controls the charge of storage battery to separate supply current for the train low voltage circuits. The steam generator is needed for the passenger ambulance train for the cold weather heating. The air compressor with the two compression cycle compresses air which is stored in the main reserve, and air in the train brake system is supplied from this source. A diesel electric locomotive has the fuel and water tanks. The fuel contains the fuel oil operating engine. The water expansion tank is the engine cooling system designed to carry off the excess heat of the engine. Truck carries for the weight of the locomotive superstructure, distributes it through the wheels to the rail. Trucks may be either 4 to 6 wheels. Later provides a greater working surface on the rails, thereby greater traction after pulling power than a four-wheel. Section 2, Preventive Maintenance 2.9, General. A well-manned, planned, well-executed preventive maintenance program results in generally operating efficiently and increased availability. Railway equipment preventive maintenance is important for any of the overall maintenance program. Not only does it safeguard against the emergency, it also reduces the cost of replacing parts. Although the weight of the diesel electric locomotive ranges upward from 25 tons and their horsepower at 150, the same general preventive maintenance procedures apply to all them. Some of the important preventive maintenance check services of the diesel electric locomotive are discussed in this section. However, they are not in all conclusive. No satisfactory substitute has ever been found. In common sense, known conscientious equipment operators inspector limits in the inspection to take any set checklist. He is constantly altered in any of the defects of the equipment and for a sign that leads him to believe the developing defects. For example, the locomotive engineer observed the defective electric wire. He would not attempt to operate the locomotive until the defective has been checked thoroughly and necessary repairs are made. The checkpoints have given only the guide of the good and preventive maintenance. 5 paragraphs follow to discuss oil, water, fuel pressure commutator checkpoints to be inspected. Then the next 3 paragraphs turn to discuss the engine overspeed trip and the ground relay and the engine receptacles. 210, the oil checkpoints. The oil level of the diesel engine pressure for the oil must be checked, as well as the oil level in the engine governor and the air compressor. Details are given in the subparagraphs following. Oil level in the diesel engine. Check the oil level of the diesel engine by using the bayonet-shaped dipstick located in the side of the engine. Location of the marks are used in the dipstick shown in the figure 2.6. When the engine has been stopped for the 30 minutes or more, most of the oil will be drained into the bottom of the engine. At the top, the oil level shown in the dipstick should be above the full mark, with the engine idling. The oil, the hot or circulating through the engine, reading the taking at the time should be showing the oil level in the dipstick when low and full. This is an oil level in the dipstick that looks like a banana. Lubrication oil pressure gauge. The lubrication pressure gauge. The diesel electric lubricating system oil pressure gauge is located in the locomotive cab. Observe the gauge frequently as the locomotive is being operated. Investigate any deviation to normal readings and proper oil pressure. Cause excessive engineering where possible engine breakdown. Locomotive oil supply and engine governor. The engine is equipped with a governor to regulate the speed according to the various throttle settings. The done and alternating amount of the fuel introduced in the cylinder. The governor has its own lubricating system for the 2.7. It shows the oil level side of the gauge on the type of engine governor. This gauge has two marks. The oil level should be between them for safe operation. This is the oil level gauges on top of the governor on the engine, which has its own lubricating system. The lubricating oil supply of the air compressor is discussed by paragraph 2.5. The air compressor is needed to operate the great deal of the equipment of the locomotive and it has its own oil pumps pressure lubricating system. When the engine is stopped, the oil level in the compressor crankcase is checked. The bayonet-shaped stick is located should be in the figure 2.8. The level should be between low and high marks. 2.11, the water checkpoints. The Army diesel electric locomotive had the water-cooled engine carrying out the preventive maintenance procedures. Both level and temperature for the water must be checked. Subparagraphs A through B and B give the details and figure. This is the water check pump and the fuel gauge. Level of the water used cooling the diesel engine the level of the water used in the cooling this diesel engine stored in the reserve equipment with the gauge shows that the marking on the typical one. The water lever should be between low and full of one of the readings depending upon the engine is running in the stop. The engine should not be operated. No water appears in the gauge. The temperature. The engine water temperature gauge is locomotive cab should be temperate in the water engine cooling system. Recommended to open temperatures on the different locomotive models. One of the ranges is 160 to 170 degrees Fahrenheit, another is 175 to 180 degrees Fahrenheit. After the engine out of the later model is started, the idles until the temperature is 120 degrees or before pulling any cars. 2.12, the fuel checkpoints. Each locomotive has 2 fuel checkpoints inspected before operating before operating the engine. There are fuel flows, glasses, the fuel cutoff valve, discusses subparagraphs to the file. Flow located duplex filter assembled for the two-flow fuel flow sight glass. The fuel flow of the right glass. One of the nearest engines should be clear of the free of the bubbles of the proper engine operation. Figure 210 shows the duplex filter assembly for the two fuel flow glasses. Cutoff valve emergency accident for the cutoff valve can be tripped and pulled in the cord to supply the fuel engine. Whenever the fuel valve is tripped, it must reset. Must be open to the engine operating. Looking into Figure 211 for the yoke normally holds a valve open, but the lever is raised. The yoke will also come up and depress the valve seam. Stops the fuel flow. To reset the valve, the lever is depressed and making the yoke slide into place, rising the valve stem. Fuel is once more flowing into the engine. Here's the flow, the jokes. The yoke in the valve. The lever stem yoke set position, trip position. 213 air pressure checkpoints. Control instrumental panels containing the many different gauges. Switches may be located in different places of the locomotive cab. Arrangement may be with each diesel electric motor. They are always conspicuous place. Instrument placed and normally contains in two air gauges, one to show the air pressure main reserve and the other to show the pressure in the brake pipe cylinder. The gauge is tested once every 3 months whenever the irregularity is noted. An accurate test page dead weight tester is used in making the tester, and any other error found in the incorrect is repaired before being used again. 214, the communicator checkpoints. The main generator is turned on the direct drive connection with the diesel engine. Electric current for the generator produced is passed with the communicator with the brushes with the locomotive. The electrical power. Figure 212 shows the alternator slip rings for the AC power to the roof cooling fans, the traction motor power, blowers,